Good morning, good evening, good afternoon for everybody, depending on where you live. Thank you so much for joining us today. This is our community call, AVM community call. We try to do those every quarter, so to speak. The last one was a bit earlier, July. Um, we have actually a packed agenda, no surprise. So we'll get started. And actually, the for those who know us, you know this slide. You know that this meeting is recording, is always recording. We post it on YouTube, so that's great because everyone can catch up. But also it gives you the opportunity right now, if you're not comfortable being, because the name you register when you enter the meeting might be seen. So if you're not comfortable with that, please feel free to step away from this meeting, and then you will catch up with the recording. So there's no problem. Also, we tend to go a little bit beyond from time to time to the hour. So today might be the case for maybe 5 minutes or so. So again, that recording will help you catch up if you cannot attend fully. The AVM team, for those who are in the community for some time, you know pretty much all of those faces, maybe except Amit on the bottom right, who joined us recently in the core team as a PM, as a program manager. So welcome, Amit. And the rest of the crew, you know them. And let me walk you through the agenda for today. First, we're very pleased to welcome our partner NickCredit. Jack is going to host Tuna from NickCredit, and Tuna will explain a little bit how they adopted AVM, why, and what they did to make it really appealing for their organization. Thank you, Tuna. Thank you, Michael, to join us this morning. The second topic, inner sourcing, will actually be quite linked to the first one. So Jack will walk you and us through this topic and what are the recommendations that we have. There are many ways to inner source AVM, and so we'll share what we think is the most relevant. Then, if you remember, a key topic in July, it was about Copilot experiences. So we want to follow up on this topic because there's so much going on in that area. Things are moving fast. It's even a bit the wild west from time to time. So actually, Sebastian will level set and try to clarify a little bit what can be done, which scenarios can be enabled greatly with Copilot. And then Stephanie and Steven, they are based in the US, so they could not join us live, but they recorded some videos specifically for what they develop in their team, the Bicep engineering team and the Terraform engineering team in that space. So thank you for them to pre-record that. December, we were planning to be V1 actually, but we're not yet. So obviously you need an update from us. So Jack will share a little bit where we are with that key milestone ahead of us. And then we'll finish by a few important updates specific to Terraform and the ones from Bicep. As usual for the Q&A, we try to put a few minutes at the end, but of course use the chat, put your questions, and we'll try to answer them as we move through the meeting. Without further ado, Tuna, please take over the presentation, and the floor is yours. Thank you.
Thank you, Charlie. Thank you, Jack. And good morning, good afternoon, good evening, everyone. First, we will start with representing NickCredit with Michael, and then I will be talking about the technical parts of the NVM and how we adopted AVM. And then, yeah, we can start maybe, huh, Michael?
Yeah, sure. Yeah, I promised Tuna just very, very shortly to say a few words of who's NickCredit. NickCredit is the third biggest bank in Denmark. And we are also the biggest Danish supplier of real estate mortgage loans. And we have had an accelerated, let's say, process of adopting Azure services and are really pushing hard to the infrastructure as code principles, which is why we set this project into motion of adopting AVM and they say adding this extra layer on top of it that Tuna will present. So I'll give the word to you, Tuna.
Thank you, Michael, for the brief introduction. Yes, we will present Nucleated Verified Modules. It's an overview of Cloud Solutions team. It's an initiative that we've started like 5 or 6 months ago. And we wanted to have this presentation because we just want to be an inspiration for the people in the community who wants to adopt, use AVM, but unsure of how to do so. It's not going to be a boring presentation. There will be less talk, but more visualization and more coding parts. So I will first talk about what is Nucleated Verified Modules and why are we doing this? And then I will be talking about how are we doing this? And lastly, I will try to finalize my presentation with a quick demonstration. And the chapter 1, what? So let's just try to explain what is Nucleated Verified Modules. It's an initiative that abstracts away the intricacies of infra deployments by providing ready-to-use IAC templates that are fully aligned with Nucleated's policies. We offer, as Cloud Solutions teams, we offer off-the-shelf resource deployments, comprehensive documentation, and of course, the maintenance by the Cloud Solutions team. Too many words, I know. So let's just try to do some visualization. I think up to the second layer, we've already familiar with those technologies and the tools that we have. Nucleated Verified Modules is a solution that is built on top of Azure Verified Modules. We do not change the source code of AVM. We don't fork it, nothing at all. We use AVM modules as they are, and we are making them in full compliance with Nucleated's own enterprise scale guardrails and policies. And what is the role of Cloud Solutions team? Just to summarize the NVM in a very short format, we receive Azure Verified Modules as they are, as an input, and we are well aware of our policies and guardrails, how to enforce them. And on top of this, we also want to provide this naming convention among all of our application landing zones. And the output becomes Nucleated Verified Modules. About this naming convention, I will be showing this in the demo part as well. So what's the value that we propose? Of course, we have a single source of truth. It's like an intrinsic nature, the feature of IAC tools, isn't it? So repeatable and consistent deployment, of course. And we believe in the power of simplicity. There will be one bicep file and one parameter file, and also a workflow file. So with these 3 files, the application landing zone owners and the contributors, all of them will be able to track their infra deployments and manage them consistently. We also provide comprehensive documentation, which I will be showing in the demo part as well. And of course, as I mentioned a couple of times before, we have 100% policy compliance. We make sure that once our colleagues in Nucleated deploy their infra using NVM, Nucleated Verified Modules, they will not receive any deployment errors because of the policy violations, no red lines on the terminal. Okay, it was a good brief introduction. Chapter 2, why? So why are we actually doing this? What's the justification behind of it? We had some known problems within our organization. The first of all, that we have too many teams in Nucleated, and all of them were doing their own IAC developments without cross-team coordination. And then all of them were maintaining their own local modules. Some of them were using AVM, some of them were not. And we just wanted to make sure that this is like a centralized hub within the Cloud Solutions team, so that we can just share a simple sample set of modules to everybody use in Nucleated. Inconsistent naming convention. Yes, teams were able to deploy their infra using their own modules, own maintenance, but their namings were completely different. Some of them were using CAF naming convention, but some of them were completely different than what we want to have in our tenants. Support bottleneck, one of the most important things that we have to figure out somehow. Teams, different teams were deploying their own resources. Yes, as I mentioned before, but once they receive any policy error, any kind of deployment error, they were just trying to talk to us to solve their problems. But first of all, we have to understand how they developed their own modules to be able to support that. Plus, we have to fix that issue. So there's like a two-phased approach before we solve the actual problem itself. And high maintenance overhead, of course. The team's burden with manually updating code bases. As I mentioned a couple of times before, teams were storing their own modules and they were trying to maintain them. If they were using AVM, of course, it's a very good thing for them because like they're just offloading most of the responsibility to Microsoft people. So they don't have to deal with that too much, but we just wanted to have this central hub for module deployments. So how can we solve these problems? We believe in a butterfly effect. In the first wave, we as cloud solutions take care of the intricacies of infra deployment, as I mentioned in the first slides, and by providing these ready-to-use IAC templates. In the second wave, we believe in the separation of concerns, of course. The developers, our developers from other teams, will focus solely on their applications. And because of this, we believe that we will have a boosted solution deployment with enhanced utilization, of course. In the chapter 3, I want to go through how does the journey to well-architected application landing zone in Microcredit look like. In the first phase, the evaluation phase, of course, the application teams should evaluate their readiness for the clouds by validating their technical fits. In the second phase, once they're ready to be going to the clouds, they're coming to us, the cloud solutions team, and we are provisioning the network foundation for them, the virtual network, NSG, UDR, and all of those access groups, entry groups, and service principal as well. In the third step, they are responsible with creating their own IAC repository. It could be in GitHub or Azure DevOps, preferably GitHub. And then in the fourth phase, they are coming to our Microcredit Verified Modules repository, which is available to be used by everybody in Microcredits. And they are only copying the necessary module templates from the repository, just like what AVM is giving to us, actually. And the strong thing that we are providing is that there's no need for expertise. They will be using these templates with ready-to-go templates, ready-to-go usable modules. And then lastly, the inner sourcing parts. I'm sure that Jack has a lot of things to mention about this, but we also support inner sourcing because we believe that as cloud solutions teams, we are the responsible people with this maintenance of this code base, but we also believe in the sourcing parts. Everybody in Microcredit can open issues within our repository so that they can just like request some features or like bug fixes and so on and so forth. So yeah, this is enough to talk. Let's just jump into the demo parts. In here, we have a very simple application landing zone use case. I have two function apps, and both of them are using storage accounts, and I also have these subnets definitions here. For the sake of simplicity, because of the time constraints, I only want to focus on the red rectangle parts, in which we will try to deploy a key vaults, and the Flex function app will be using its own system assigned managed identity to retrieve a secret from the key vaults. And that's all. These screenshots are coming from our own repository, AVM repository, Microcredit Verified Modules. And as you can see, we have version history, and all of our developers and other teams can see what has been done and what are we trying to work on. On the second and on the right-hand side, you can see the deployment steps parts. On the contrary of AVM, as you may have already known, that AVM is giving to us a lot of different templates for different use cases, like WAF aligns only standard parameters, only mandatory parameters, and so on and so forth. But in here, we are only giving us a single bicep template, so that it will be a generic general module to be used by anyone in Microcredits. I need to deploy a key vault, so I'm just like copying this code from here. On the left, you can see the bicep code, and on the right, of course, you can see the parameters codes. I have a couple of things to mention here to bring an added value to AVM. What have we done? And I think the first of all is going to be the naming convention. As you can see here in the parameter file, we are not asking for the final resource name of the key vaults. We are only asking for parameters that are necessary to populate the final resource name of the resource. Too many resources, yeah. So what is happening is that in the key vault module itself, we have developed a local naming module, and this naming module is called within the key vault module itself. So that I'm not asking for the final resource name. Plus, the second thing that I want to mention is that in our setup, in our architecture, the ordering matters. What I mean by order is that, okay, I can just copy those codes from the NVM, key vaults, function app, storage accounts, blah, blah, but I have to somehow connect them together, right? Because this function app needs to have this RBAC role, key vault secrets officer, on this key vault resource. And as you can see on the left side, I have function app module 0 index. I know that in the parameters file, in the 0th index, I have this flex function app that I need to see it as like a connected resource to key vault itself. So by providing these indexes, I can actually link them one another. The drawback of this strategy is that we have to keep in mind that the ordering matters in this parameter file, huge parameter file, like key vault, storage accounts, and so on and so forth. But the plus of it is that you will only have a single parameter file and a single bicep file, and that's all. It will be ready to be deployed. Of course, after we deploy this code with AZ's deployment sub creates, then we have this resource deployed, following the naming convention, of course. And then I have already deployed the Flex function app, and its managed identity has necessary RBAC assignment. So within a single deployment, I have deployed the resource groups, resources, and also the role assignments. And that's all. Tak means thank you in Danish, by the way. So thank you for having us, Jack, Charlie, and all of the people and brilliant people at Microsoft. I hope that this was a valuable information for all of you. Yeah, thank you once again.
No, thank you to both you, Tuna and Michael, for reaching out and getting involved here and wanting to present. These guys reached out completely out of the blue to us, right? So that proves that we really do pay attention to emails, and like you can get in touch with us in many ways, and we're willing to listen. So this is a great topic and one that I'm going to talk about in a second. Just I think some key takeaways there that I heard, Tuna, that is important. Like you don't change the source code of the AVM modules. You just add in your additional wrapping to make them compliant with your policies, your naming conventions, and those pieces. And you're focused on the value of the inner sourcing community, right? People can raise issues, people can contribute back, all within the credit. It's not just like it's locked to your cloud solutions team. Everybody across the whole of Necredit can get involved and help, right? Which I think is a real key success pillar for most inner sourcing projects that I see fail in most organizations. So, great work, team, and thanks again. All right, with that, I'm going to take control and start going into inner sourcing within AVM itself. So it was well timed with Tuna and Michael reaching out, because I actually had this on the agenda already. And I was like, great, we've got a customer use case to back up what we were talking around. So we've spoken about inner sourcing before with previous partners, and we've mentioned that we're looking into it. What I want to do now is just share where we are and what our status is on inner sourcing, and giving you some guidance here. So we commonly hear this, right? And I think we've heard this from Tuna and Michael, that how do we make AVM modules compliant available privately within our own organization? We want to take that as a common thing we hear. Then it evolves into how do we customize those for our modules' own security requirements? How do we make sure that people using them out of the box don't bump into policies and all those things that literally, as Necredit have just shown us? And then how do we build our own AVM modules and publish them to our own registry or like our own private sources so that our customers can consume those internally? These are sort of like the three common pillars that we often get asked around the topic of inner sourcing, whether the customer knows it or not. And the answer is very, very straightforward, right? It is inner sourcing, but where it can be very complex, right? And we've seen some very, very complex inner sourcing solutions. But there can be easier and simple ways to achieve it, and also to unlock and answer those common asks that we've seen at the beginning. So we have been working on this behind the scenes, right? I've been taking a bit of a lead on this and writing a paper internally for us. And we've defined some principles that we want to set everybody true with when they're starting their inner sourcing journey. And the first one is pretty much what Nicredit shared first straight away in the solution, which is the AVM modules themselves must remain as is and unaltered when inner sourced. We quite often see customers who have tried to inner source AVM try and change some of the module, and then they get an issue and they try and raise an issue back to us, and they're like, well, hang on, our code's a little bit different because we tweaked this thing and it's not the same as that anymore. And it makes it really hard to support and maintain, and also for you to contribute back nice and easily. So the first rule we're saying is don't change the AVM module. If there's an issue with the AVM module, contribute it back upstream, raise an issue, and let's fix it there, and then pull it down when it's fixed. Don't edit that AVM module, or if you do, be aware that you've done that. When you then need to customize that AVM module, so make it comply with your own policies, put your naming standards in, all of those things that Nicredit just showed, do exactly what Nicredit showed, right? Wrap it in another module that you publish. So you're calling as sort of a child module or a cross-reference module within there, the underlying AVM modules, but you're wrapping, and what you're getting your customers to consume internally is the wrapped module that you've built and published, where you've handled all of these, hiding default values, removing some of the allowed values that you don't want people to use, hard coding some of the parameter inputs or variable inputs because you don't want people to ever set those. All of those things can be done in your wrapper module that wraps and calls the underlying AVM modules. And then when your organization does publish a module, builds one or builds a wrapper module, you should build them to the same classification and specifications as published in the AVM documentation. And the reason for this is mainly a political one. If you follow this, it's very easy for you and your organization to say, we're just following what Microsoft are publishing and saying. And it's not, oh, this is this person's opinion or this person's opinion on what good looks like, because you'll find that that'll always cause friction within an organization. If you can shift that onto Microsoft and say, we're just following what Microsoft already do, it's a very hard argument for somebody to go against, knowing that there's quite a large consumption of AVM and it's a very, popular project. So these are the principles that we want to share, right? That you should always think about when you're inner sourcing. But the top one is the most important. Do not change those modules. But this is all, theory. How do we actually do this? So I'm going to dive into Bicep first, and talk about how you can actually achieve this. So here's a diagram that I put together, actually whilst on holiday, because that's how I relax. So this is on the left-hand side, we've got what Microsoft already own here today. So we've got the PRM repo, and we've got the Microsoft Artifact Registry, or MCR, that you'll know fronts the registry. So we push all of our modules into there. And then what we're saying on the right-hand side of this diagram is these are the parts that you can now deploy. So you can deploy your own Azure Container Registry. You can optionally connect up your own GitHub repo, and we'll talk about you might not need to do that. If you only want to achieve the private element, you might not need to do that at all. And then obviously your developers, your consumers, yourselves only have a point to the Azure Container Registry that you can control to get your modules from, and you change your paths, right, to use that. And I've actually recorded a very brief demo of this, so I'm going to talk over it whilst it goes. What's going on here is we've got let's go back to the beginning. So we've got a container registry, and it's the standard SKU. And you can see here there are no repositories configured, which means there are no modules cached. So we're going to use the ACR caching feature to create a rule, and then you can give the rule any name you like. And then we're going to choose a source of the Microsoft Artifact Registry, and we're just going to add on to the end bicep/avm/star, which means every AVM module. And then we're going to set the new ACR repository namespace to be avm/star, which keeps it in sync with the path with AVM of what we've got today.
Can you put it
That's
full
really
screen?
easy. I can't go full screen because it will go massive.
Okay, sorry.
So as you can see, we've got no repositories here, and we'll publish this to the YouTube channel anyway, so you can look at this afterwards. So once you go into your VS Code, you need to set up a bicep config JSON. And what you can do here is you can override BR public. So BR public will point to the public registry that we published today. But if you put that in your own registry path and you set the module path to ... which negates one of the namespaces we need, you're now ready to set up. You're not going to consume from the public registry ever. You're only going to consume from your own. So you can start calling your own modules. And you put in the path as if it was, all you're changing here is the registry name. You're leaving the rest of the AVM path exactly the same. So you'll see the resource group here. Now you may have seen it went initially red and then it went green and carried on. That's because it forced your ACR to go and pull that module locally into itself as a cache, following that cache rule, which then pulls it all in and you can use it as any module you normally would. You can also use now the BR public address space. So if you've got existing templates that you've already written that point to that, very easy to migrate and start consuming these privately. You can just change it here and you can see it's already said, yeah, I know you've got that module cached. But we could also, change the version of that module to a later version. It will go and pull the same module version and all the versions stay in sync in the caching rule. So if we've changed it to 0.4.1 here, it'll go and pull in 0.4.1 from the public registry and off you go. So really, really easy to set this up and get going. Like that is literally a live demo. I've speeded up tiny parts of it, but it took me less than 5 minutes to do this. And then you can go and configure and do all these bits and pieces and, start a deployment. So I'm just creating two resource groups here, one using the direct reference to my private registry and another one to the BR public, which is actually using the same. Because I've done that bicep config override of BR public. And you're going to see the spinning wheel go crazy in a second because I speeded this up because we don't want to sit and watch a deployment happen. And there we go. So if I now go into the module registry, I can see I've got the resource group module here with the 2 tags of versions that I've declared. And you can see we've pulled in those artifacts into this ACR. So really, really simple to set up. And therefore that code is only being called internally. So that's like the first step and answers that first question for most of you when you're trying to inner source. Now, if I go back and present the deck, give me a second. For it to do its thing. And let's get back to where I was. So this is a very quick overview of how this works, right? So you declare in your bicep file the private registry that you've created or using the bicep config override. The repository then goes and says, hey, have I got this? If it has got it, does it exist? And like, does AVM have this? Yes, no. If it matches a cache rule, it will go and try and pull that from the AVM. It will force your ACR to go and pull it from the public registry and then pull that module version back into your ACR, which then you can consume. So all very straightforward, all using that caching rule feature, which has been there for a little while, but we've now worked out how we can use that with AVM. So really, really simple. So that's a way of doing it. Now, you could obviously then publish and set up your own GitHub repo to publish your own modules with your own logic to that ACR as well. But that's completely your choice. And that's down to you on how you want to manage that publishing process and versioning, right? We aren't going to be prescriptive on how you do that today. And this is just one of the recommended approach, right? There's many other ways that you could do this, but this is what we feel is the simplest and safest and most sort of stable approach of doing inner sourcing very quickly from a bicep perspective. Now, I already see a question in the chat about Terraform, and I'm going to start off saying I'm sorry, like it's not as easy. And there are a few things to be aware of. And Jared and anybody from the Terraform side, please feel free to pitch in if I go off piste here or get a lot of things wrong. But you've got many options to choose from, right? You've got HTTP Terraform or Terraform Enterprise. You've got other private registries like JFrog, M0, Spacelift. Like there's thousands out there that all follow the Terraform private registry specification or the Terraform module registry specification, which is an open source specification that you can follow. You can even put it in anything that Terraform can read, right? You could just store it in GitHub. You can store it in ADO and use Git references or anything like that. It's completely possible to do this with Terraform. But the one thing that you need to be careful with Terraform that makes it a little bit more complicated is you need to be careful of modules that cross-reference other AVM modules. Because if your goal is to purely make this private and never call the public registries, What you do in Bicep, because the template, when the Bicep module is built and published, it resolves all of those sources into that specific module itself and then publishes it there. So if we're cross-referencing modules, all of that code is sucked in and published as that one artifact of the module that's being published. In Terraform, it doesn't work like that. In Terraform, it'll actually go and call each of the other modules and pull them individually from the Terraform client itself when it's running. So when you've got a module that you've pulled, for example, maybe the resource groups module in, it'll have a reference to probably the utility interfaces module, which manages all of our shared interfaces. It will pull that from the public source if you don't go and change the source. So you will need to build some automation that goes and basically does a find and replace, like from this source, the Azure public registry source, to wherever you're hosting it yourself internally. There is no feature in Terraform yet. There's a long-running issue that you'll find in the Terraform repo about this that happens. Like this is a known issue and something that is a bit of a pain point when you're trying to inner source these modules. You also need to think about providers, right? You can also inner source providers, or you may choose to say the providers are fine to be hosted publicly. It's just the modules, all completely your choice. But there are lots of options in Terraform, and we aren't going to say this is the one way to do it, like we can with Bicep, because it's a more Azure native solution. We can certainly give guidance, but we can't say this is the only way you can do it, because there's many ways. So this is the one thing to really be aware of about the cross-referencing, and then it's really pick your poison, like which one do you want to go with, and off you go to the races. And you can then follow the same approach, right? Set up your own Git repo to publish and push modules into your own registries, or however you want to manage that. But it very much depends on the solution you pick. So going forward, what can you expect from us? Right, we're going to document this with guidance and notes to the AVM website, hopefully by the end of January. I should get it done before then. Hopefully I'll get it done sooner. We'll continue to listen and take feedback in on what we've published. So please do give us issues once that's out there and give us feedback. And I think this is the most important point at the bottom as well, is for transparency. We will still remain on adding features and publishing into public registries, right? Inner sourcing is something where you're providing guidance so that we can unblock some of you who have this as a problem. But I think I really want to put everybody's mindset of only inner source when you really have to. Like, it's not a thing you have to do by default because it sounds cool or because it sounds like, oh, it makes us more secure. I would argue that it probably gives you more holes and more things to protect. If you've really got a valid use case to inner source, then fine. But if you haven't, don't go down this path, because you're just going to make your lives a little bit more complicated than they need to be. So yeah, that's where we are with inner sourcing. I see there's some questions in the chat. I'll get to those. But with that, I think I'm going to hand over to Sebastian to talk about some Copilot stuff.
Copilot stuff. Thank you, Jack. I'll take control. All right. Everybody can see the slide?
Yeah, all good.
Yep. Good. So fine. Yes. So I'm coming from the angle from GitHub Copilot mainly, and we want to share some experiences in terms of infrastructure as code. Stephanie and Stephen, they're not present in this live session, but they have provided us some videos, and we're going to share this as well. So what I am going to talk about is how the AVM team mainly is using Copilot, how we work, but also what you as an end user consumer of AVM modules can do in this terms of right. Just a bit of overview. I know we also understand that some people of you are still new to GitHub Copilot. There's a lot of movement at the moment over the last weeks, months, and also years. I understand, or we understand that a lot of people are using GitHub Copilot and all these different flavors. So this is a table just to check through in the word demystifying everything around that a bit, just to give you a bit more broader picture that everybody is aware of what's actually going on. This table gives a bit of an overview, and I think some people might know when we talk about code completion in chat. So at the very, very first beginning of GitHub Copilot, we had code completion, right? When we had no chat available yet in VS Code, there was just code completion, which was always a brain mind-blowing, where just code was completed just out of magic, right? Then we have chat at the moment, which was just with asking and planning, and then we had starting to edit code. What I'm going to talk about and going to show quickly, quite some 1-2 minutes demo, how the agent mode works, the coding agents, but also the code review. So this is everything aspect of the GitHub Copilot universe. And then we also have like CLI and github.com. So this is just a table just to highlight and emphasize with what's currently out there, does it do. And what I mean with sync async, this I think becomes a bit more interesting over the next month when we talk about background agents, agent-to-agent communication. So there's probably something coming as well. But basically what it means async is that we already send tasks to our coding agents who can take care of taking activities in the background, right? That's pretty much what it means. So at the bottom, you can see that what is really helpful are GitHub custom Copilot instructions. We can talk about agents already inside. I mean, I'm mainly talking about GitHub Copilot when you use it using Visual Studio or Visual Studio Code. You can use it, create your own agents in the meantime, but also you have some prompts. And this goes towards our one of the famous awesome Copilot repositories. Where I'm going to show you as well a bit, and I think you should be able to click this link here, which gives a really broad inventory of really amazing instruction files, agent files, prompt files you can make use of. So feel free to have a look. What to mention here is that we are in the process from AVM to transition some of these code instructions, and it was formerly said chat modes, which is now changed to agents, the agents files in these repositories. We had some of them in place that are also currently in place on this repository. They get updated. So just keep in mind, because of a lot of moving things and everything goes so fast in the last weeks and months, we are updating these files as well, but they're still usable. Demo. So let me share the screen. I'm trying to be quick. So what I'm going to show is, and I'll have to present a few from Teams that's showing it to me. So quick rundown. So GitHub Copilot coding agent. If you're not familiar with it, what it actually does, we're looking at it starting point from an issue perspective on GitHub, right? So this is a repository. It's around a AI Foundry pattern module, which we're working on over the last weeks and months. And you can see it's already public. This is Terraform, by the way. But everything what I'm showing is also applicable to any of the bicep modules or the bicep repository where the team is working on. And so my starting point is here. So since we're working on this Terraform module, there are already coming in issues on the public space from people leveraging this module and creating issues, right? And usually the power of GitHub Copilot, but what I'm doing is when I have not so much time as the owner of the module to go each of these issues, I just go ahead and say, okay, wait a second, there's an issue which is like, okay, semantic search switch is broken. I have a quick look at it. So someone was, okay, there's a bug, looking at, okay, reading through it. And what I'm doing, instead of spending my whole effort, I'm just going ahead and say, hey, Copilot, take care of it, right? I don't even give any additional instructions or something. I just say assign it, because I know based on the input and the issue description, the person opened this issue, the GitHub Copilot coding agent will be able to understand just with this minimal amount of context. So what's happening is you can see that it's assigned to Copilot, and what it's going to do, it's going to create a pull request for us on the fly. So I'm clicking on this pull request, and you can see that it's starting to work on it. And it's starting to work in the background using GitHub workflows and GitHub actions and trying to solve the issue, right? I'm not going deeper into level, but you technically, for people who have used it, they're probably familiar with it. So you go into the session and you can just watch what GitHub Copilot is doing. So this is then this space where you can see it's running through the actions, it's running through, and it's trying to find a solution for it. And what the AVM team is leveraging here is we are using certain custom instructions which are spread across all, in this case, all of our Terraform repositories, which give the GitHub Copilot coding agent certain fine-tuned instructions in order to better solve these issues on an AVM-related perspective. Okay? All right, this is coding agent. Let me quickly switch to a simple code review. So this is a very simple approach. So I think usually we have some of our chore pull requests coming up on a weekly basis when we have to update some of our repositories. This is the same for Terraform, but also I think on the bicep side. Alex, correct me if I'm wrong. But I'm just picking any random pull request. And so this is a good example. It says this PI contains pre-committed. Okay, not really explainable. So I have to look into the files, but instead of looking into the files, spending effort, let's just say, Copilot, have a look at it. Right? So I just assigned it to Copilot, and I said requested a review. And then what's happening, Copilot is looking at the files, and I think within a couple of seconds, I'm not quite sure what the workload is at the moment, it comes up with a pull request code review description, and it just gives me some more info without me having to spending time on browsing through all the code. So this is the simple GitHub Copilot code review. So you can see it started reviewing on behalf of me, and I could jump into the session, and as output, it will add a comment onto this pull request, giving me more status. While this is running, I just showed the last bit, which is the awesome GitHub Copilot. I will come back to this in a minute just to show you that it worked. The awesome GitHub Copilot customizations repository, which is becoming quite famous over the last weeks and months, where it's as I said, it's a huge inventory of instructions, agents files, and prompts. And they also started to create collections out of that. A very good feature is if you just go ahead, browse through it, have a look at it. We also have some of the AVM instructions, but as said, they're going to be updated and more aligned to the current and the latest states in terms of agents that you can properly use it in VS Code. I'm just going to, let's say, awesome agents files, having a look at this. And if you look at this, they have quite cool install buttons. We all like these install buttons. And if you can see, by the way, VS mode is amazing. If I scroll down, go to AVM bicep mode, AVM Terraform mode, you just click on install. I have VS Code Insider's version open, so I just click on install. And it should open up. Yes, it should open up and ask me. And it's switching to my VS Code. By the way, this is VS Code Insider. This might look different to your Visual Studio version in case you haven't used it before. And I just say yes. And then it says, okay, where do you want me to store this agent file, such as user data? I said, okay. And then what happens? It shows me that agent file, and you can see under your Copilot window, you can see that all these agents are popping up under the agent second as a custom agent. And that's pretty much it. Let me just switch back to the code review. Let's see if it already finished. Yeah, see. Quite perfect. So the Copilot looked at the code. It gave me some information what it's actually going on. And I did not have to spend 1 minute looking at the code. So this is how our team works. That's how I work. And everybody has a different perspective. Okay, let me stop sharing and go over to Charlie, just help me. Do we see still the slides? Do I have to reshare them, or does anybody else?
Yes. Do you want me to reshare? I can do it right now.
Yeah, it would be good. Thanks.
Okay.
Yeah, I think you have them open. Thanks for that. And I am going to the last 2 slides, which is about the MCP slides. This one, right. So this is from Stephen Ma from the Terraform PG. So he proves with this video that how Azure Terraform MCP server can automate the exporting of export of Azure resources to Terraform. Then it validates them for compliance. I think it's using AI-powered remediation or something to produce a production-ready code and also compliant infrastructure as code. So let me just start that video.
Hello. Today I'm going to demonstrate the Azure Terraform MCP server and show you how it streamlines the process of exporting Azure resources to Terraform and ensuring they meet compliance standards. In this demo, I'll be exporting an Azure resource group called MCP Demo that contains a Linux virtual machine and its associated networking components. Let me walk you through what happens when I ask GitHub Copilot to export my Azure resource group and validate it. First, the MCP server uses Azure Export for Terraform, also known as AZTFexport, to automatically export all resources from the MCP Demo resource group. This includes 9 resources total, the resource group itself, a Linux virtual machine named vmexample, an SSH public key, a network interface, a network security group with its association, a public IP address, a virtual network, and a subnet. The export process takes about 30 seconds and generates several Terraform files: main.tf with all the resource definitions, provider.tf with the Azure provider configuration, terraform.tf with the required providers, and a terraform.tf state file to track the imported resources. Next, the validation phase begins. The MCP server runs tflint to check for Terraform best practices and code quality issues. Initially, tflint identifies one warning. The Terraform configuration is missing a required version attribute, which is important for ensuring consistent Terraform behavior across different environments. Then, Conchtest runs to validate against Azure security policies. It checks 2 comprehensive policy sets: the Azure Proactive Resiliency Library version 2, which contains 77 resiliency checks, and AVM security policies with 49 security validations. Conchtest identifies 2 compliance issues. First, the public IP address needs to be configured as zone redundant with at least 2 availability zones for high availability. Second, there's a check about availability set configuration for the virtual machine. Now comes the automated remediation. GitHub Copilot, powered by the MCP server, automatically fixes these issues. It adds the required version constraint to terraform.tf, specifying that Terraform 1.0 or higher is required. It updates the public IP resource to explicitly define the standard SKU and configures it with zones 1 and 2 for zone redundancy, ensuring high availability across multiple availability zones. After applying these fixes, we rerun the validations. tflint now passes with 0 issues. Perfect. Conchis also shows significant improvement, with 78 out of 79 Azure Proactive Resiliency checks passing, and all 49 AVM security checks passing. The remaining availability set warning is actually a false positive. The virtual machine is already using zonal deployment in Zone 2, which is the modern, recommended approach for Azure VM resiliency and is superior to the older availability sets model. So what did we accomplish? In just a few minutes, we exported 9 Azure resources to Terraform, identified and fixed compliance issues automatically, and ended up with production-ready Terraform code that follows Azure best practices for security and resiliency. The key benefits of this Azure Terraform MCP server are automatic export of existing Azure infrastructure to Terraform using AZTFexport, built-in validation with tflint for Terraform best practices, comprehensive security and resiliency policy checks with Conchtest, and AI-powered automated remediation of compliance issues. This demonstrates how the Model Context Protocol enables seamless integration between GitHub Copilot and specialized tools like Azure Terraform Export and Validation utilities, making infrastructure as code adoption significantly easier and ensuring compliance from day one. Thank you for watching this demonstration of the Azure Terraform MCP server.
All right, so thank you very much for that, Stephen. And let's just go, I know there are a couple of questions in the chat. I'm trying to answer that as well, but let's just go to the last video, which is from Stephanie. which is about a bicep MCP server. So let me just see if I have the right slide. Yeah, all right, let's start. By the way, this is a bit slow. Let me just pump up the volume. If in case you can't hear it properly, just pump up your local volume as well, please.
Hi everyone. So back in July, our team was working on improving our Bicep agentic AI support, and we came to you for feedback in the AVM community call. Thanks to our wonderful engineers, we've built the Bicep MCP server and launched it in experimental. We've integrated several tools to share up-to-date recommended best practices for authoring templates, list Azure resource types and schemas for each specific provider, resource type, and API version, and most importantly, we created a tool to list up-to-date metadata for all Azure Verified modules available. Right now, this is only available in VS Code, so I'll show you a little demo on how you can utilize the tools from our MCP server here. What you'll want to do first is make sure you have the latest VS Code Bicep extension installed, which you could find in the Extensions tab, and go into the Bicep extension specifically to see which version number is installed. Our latest version was 0.39, so make sure that is the most recent installed version in VS Code for you. Next, we'll want to launch chat mode, which we could do so with this toggle chat button at the top. So you'll just want to click that. And if you haven't already signed in to GitHub Copilot, it will redirect you to sign in at this time. Right now, since I'm already signed in, we can skip that step. You'll also want to make sure you're on the agent mode listed here in the drop-down menu below. Next, we want to make sure we have the Bicep MCP tools available. So you want to click on the tool icon at the bottom, which will show you all available tools that we can apply in the chat sessions. So we'll close that out there. We'll want to make sure that the Bicep experimental MCP server is checked, along with all of the following tools in the folder listed here. Now, after we confirm that we have the Bicep MCP server up and available in VS Code, let's start using it. So I'm going to go into the chat here and tell it I want to create a web app using Bicep, and then we'll start its gears turning. So the first thing this will do is call our best practices tool to make sure that the Bicep file generated is reliable and at the best quality. Next, it calls the AVM tool for a web app, and you can open the drop-down menu here to see that it calls specifically Microsoft.web. And then it'll think a little further to search for modules, and we can open that and it says Microsoft.web sites. The tool also notices that we need an app service plan. So we'll click the drop-down menu again and see that it calls a web server farm specifically, which is what we need to create a web app. All right, it generated a Bicep template for us here using the best practices in Azure Verified Modules available. You could also see that it created a Bicep param file as well. It'll have a few parameters in that file. Now it's giving a quick summary of everything that is generated, so I'll give it a couple seconds here. And we can scroll to the top. So we'll see that it creates an app service plan and a web app, utilizes the best security features, and creates a parameter file to allow parameterization. It also gives you two options to deploy using Azure CLI or PowerShell and provides you with pre-written arguments to copy and paste into the terminal. This also shares the key features that were included in the Bicep template created, such as being production ready, secure by default, scalable, flexible, and cost-effective. At the bottom, we also see that it gives us the URL that we could immediately click once the deployment is done. So now what we'll need to do is keep both of our main Bicep and main Bicep param files. And then let's close out the chat window to look deeper into the file. So as a best practice, every time you use agentic AI, you'll want to review the generated file for errors and warnings, as well as give it a full check to confirm what it's creating. So at the top, we have some parameters created for us. The name prefix, location, environment, which I'll want to switch to test. The SKU set to the free plan, HTTPS only, and tags. I'll want to change this tag to be created by me. So we'll write created by Steph-Yen, so we'll know who is making this. We also have some generated variables for the web app name and app service plan name. And now we could go into the resources. So you can see here we have the app service plan resource definition using Azure Verified Modules for a server farm. I'm happy with all of these properties here, so let's look at the web app. It's also using AVM to grab the resource definition with some properties filled out. Let's go through those here. I'm pretty happy with all these properties, so looking at the outputs, and I'm also happy with its outputs. So let's go into deploying this file. What we'll want to do here is reopen the chat, and we can grab that pre-written deployment command between Azure CLI and PowerShell, and I'll choose the PowerShell command. Another cool feature here is the ability to insert into terminal, which we can click the button and it automatically copies into the terminal. Since I have all of my properties defined in the main bicep file, I'm not going to use the bicep param file. We can utilize this bicep param file when we need to insert different values for parameters in different deployments, and it also allows you to override parameters defined in the main bicep file. I'll also want to edit my resource group name to Steph Yen, which is the correct one. And now we can deploy the file. As you can see, we have the outputs listed here. Go up and see the parameters as well, and it's succeeded. So I'd like to share another cool feature that comes with this tool. I will close out the terminal and open a new chat editor and say, show me the different AVMs for creating a managed environment. We'll give it a couple seconds to think and run a little bit. And now that it's done running, we could look from the top. What's really cool is that every single AVM, it'll share the module name, latest version, description, and a README, which will link you directly to the README documentation. And at the bottom, it'll share the most commonly used AVMs for this managed environment ask using container apps, as well as one for an app service workload. You can continue to ask any follow-up questions, so feel free to play around with this as much as possible and share any feedback you have with us. To learn more, feel free to go to aka.ms/bicepmcpdocs, where we have information on all of the tools available today. And if you have any feedback or any ideas on new MCP server tools that you would like to see, please put them in the Bicep issue 18001 on GitHub. We're very happy to hear any feedback that you guys have. Thank you everyone for listening, and I'll see you guys next time.
Yep. Thank you very much, Stephanie. And that's pretty much it for this section. And I'm going to hand over to Jack.
Amazing. Thank you, Sebastian. All right, we are running massively over due to some technical issues this morning, but nobody's fault. So stick with us. If you can't, this will be recorded and put on YouTube, so bear with us. So I want to talk about Go V1, right? And in the spirit of AI, I've generated a number of images for this part using AI. And I want to talk about the elephant in the room, right? Charlie mentioned this at the beginning, that previously we shared we would be looking to go V1 around this time of year, but clearly we're not. And that's, disappointing for a lot of us, but actually it's not a bad thing, and there's good reason behind that, and I want to share some of that with you. So we are still making a lot of progress here, but we've just hit a couple of bumps in the road. You've probably seen a lot of us working on a number of things behind the scenes in PRs and in specs and issues and all of those things, that we're updating quite a lot of fundamental elements we need in AVM before we can get ready to go V1. So one of those being child modules. Like, we're sort of ready now in child modules. We've just got a tiny bit of documentation to finish for Terraform. And then we actually have all the platform elements ready to go, and we know how to enable this, and we've got it all set up in Bicep, and we can publish them, and like it's all good on that front. We've we invented utility modules, right, which we didn't have when we started on this. How do we get to V1 journey? So now we've finished going through all the specs, and thank you, Amit, for leading this, saying which ones are applicable to utility modules, which ones aren't, so that we've got clarity, and then we know what we need to test for in our utility modules, so that we can scale out utility modules even further. With sovereignty being a big focus for a lot of people in the world, we actually noticed that our CMK interfaces and implementations didn't support managed HSM. Bit of an oversight from us. So Alex and Erica and the rest of the team have been doing loads of work on the Bicep side to get this supported, and Matt and Jared have been doing the same in Terraform, so that we can support customers' CMK requirements with managed HSMs if they have those. So like that work's been going on. Service groups got launched. So I've been working on introducing service groups. So we've been creating resource modules for service groups, but we also need to update our shared interfaces so that when you attach or create any resource, you can automatically attach it to a service group straight away, because that's the whole idea, right? You can connect disconnected resources across multiple scopes into a service group, and you're going to see lots of things come to service groups. So they're important that we have support for them. And then most importantly, like we've added lots of things to our specs. So we need to now keep improving our tests to make sure that we've got complete coverage for those, so that we can scan those, right? So all of these are just some of the bigger ticket items that we've been working on. There's lots more things behind the scenes that we've also been working on that have sort of caused this delay. But I want to give everybody a bit of confidence here. Like I was lucky enough to be at Ignite a couple of weeks ago, and hopefully some of you also made it there or watched it online. But Scott mentioned this in his keynote around the Azure Copilot migration agent, and I just want to share that what he is talking about there is using the ALZ Terraform code that me and the team write that is built upon AVM, right? So there are product teams now taking dependencies upon AVM, which is an amazing achievement for us. And to make the keynote of Ignite is super like exciting for us. So people are still betting on us. People are still saying, yeah, this is the right thing. This is the right direction. So there is still a lot of support for AVM here. Like it's top of priority for a lot of people. And I think we have to remember, right? AVM modules are ready for production. All of you here are probably using them in production today across organizations of all different shapes and sizes. And that's, shown in our statistics. If you look at this, ignore the wavy line, right? We need to remove this from our internal dashboarding, because it's very tolerant based on a very small change, or very variable based on a very small change. But if you look at the blue lines, this is the number of deployments of AVM modules month over month since the start of this calendar year. And as you can see, it's only going up, right? We had a small dip in April. We don't really know why. We think we had a bit of a data issue, but this is a continuous trend graph going up, right? The module usage is getting bigger and bigger over every month. So we know they're being used in production in the real world, and that shouldn't stop you. Going V1 shouldn't stop you. And to echo that point, I think, V1 does not equal ready for production, like they already are. And thanks, Renee, for this graphic on top. Much needed. V1 actually means we've got stability in our specs, and we don't foresee any planned breaking changes to our specifications that mean a breaking change to our modules. That's what we really mean by V1. And just as a reminder, right, my favorite thing is when a customer says, hey, you're not V1. I had this a couple of times at Ignite, like, hey, when's AVM going V1? We won't use it until it's V1. And I push back on like, well, why? Like, how long have you been using Terraform? And they say, oh, 7 years. And you're like, okay, it wasn't V1 when you started using it then, but it didn't stop you using it then. And people using Bicep today, right? Bicep's not actually V1 itself. They've got a plan to go V1 themselves, but it's 0.39 or something like that at the moment. So you can use these tools in production today. V1 means something very different to what a lot of people perceive it to mean. So please, please, please don't wait for V1 unless you truly understand what that means. If you do truly need no breaking changes and stability and all of those things that you can't deal with a breaking change if it was to happen, then fine. But actually, as you see from the numbers, lots of people are happy taking this on today without it being V1, because they understand that they can pin to the versions, and if it works today, it will carry on working, and they can change that version, and they're in control all the time. So that's a bit of a reason of the why. But the most important part is, when, right? All of you are probably thinking, yeah, great, Jack, but like, when are you doing this? We'll provide a bigger update on this in the new calendar year on the next AVM community call. There are some internal conversations going on, like take what I said about making Scott's keynote, lots of people now taking dependencies upon AVM internally across product teams. There are conversations going on about taking that further and how do we get more and more support for AVM so that we can do more and more things and improve the quality of AVM and improve the responsiveness of AVM even further. So these conversations are going on right now. It's most of my weeks every week at the moment. So I don't want to share anything because it's not concrete, but hoping by the new calendar year it will be concrete. And if it's going the way it's heading, it'll be very positive news for all of us. So stay tuned. We are still on the journey, but we've just had to take a little bit of a pause whilst we've had some internal fun going on. And also we've found some more things that we want to add into our AVM specs. So any more questions on that, feel free to hit the chat. I'll answer. But in the interest of time, I'm going to hand over to Jared and Matt to talk about some Terraform updates.
I'm going to attempt to take control. This sometimes goes wrong for me. Let's see. Yeah. So I guess you can still see the deck, but I can't see it. So,
that's fine. I can drive for you if you want.
Okay. All right. Yeah, if you can. Yeah. Are we just on the front page? Oh, hang on. Something's coming back. Okay, I can see it again now. Yeah, if you can drive for me. Yeah.
Yeah.
So,
no worries.
In terms of going V1 for Terraform, there's some things that we wanted to share around that. And my partner in crime, Matt, is unable to make the call today, unfortunately. So you've got me for this section. So yeah, we want it to go V1 with AZ API. So we're going to be basically for V1, we want all resource modules to be AZ API, and that's completely AZ API. So there wouldn't be any Azure references at all in those resource modules, including the interfaces. And for pattern modules, we want to prefer AZ API. So ideally they would be AZ API, but we will allow some Azure and potentially some other providers where needed. So yeah, basically for a resource module to go V1, it will need to be converted to AZ API if it isn't already AZ API. So why are we doing this? So AZ API has become a lot more robust and mature over the last couple of years. We've had a lot of experience with developing AVM where we've often had to fall back to AZ API. And one of the reasons for that is that the Azure provider is manually maintained and it's owned by a team at HashiCorp. And the response time for adding new features and bug fixes can be slower than we need it to be for AVM. That's one of the reasons that we're looking at AZ API. AZ API is owned by Microsoft, and we work closely with Stephen, who did the presentation before. We worked closely with Stephen's team, and we actually contribute to the provider as well. And AVM and the AZ API team work in partnership. So that really helps us to get the features that we need into that provider and to develop AVM at scale. AZ API also has preview and GA features of resources available from day one, and quite often customers are looking to be able to leverage those preview resources in AVM, and we, depending on demand, we will support those, and we can't do that with Azure. We also want to have feature parity and consistency with Bicep, and AZ API gives us that out of the box, right? Because it's using the same API behind the scenes. So anything that you can do with Bicep, you can do with AZ API. So that's where we want to be. We also have some advanced capabilities that really help us in AZ API. So being able to retry on failure. So for eventual consistency, especially with things like role assignments, is really helpful for that. We don't have to have like timeouts and things, which are nasty and more of a guess than an actual retry. But yeah, we really rely on those features in AZ API, which are not available in Azure. And we also have write-only attributes for any resource, whereas in Azure we have to wait for that particular resource to get that feature. And going forward, we'll have things like Terraform actions as well will be available for any resource, whereas with Azure they have to be built individually. So what are we doing? We're updating our specifications. We've got Matt's working on this mainly, and we're going to have our specs in place soon, and we're going to have our automation, so our automated testing, linting, everything else is also going to be updated to fully support and favor AZ API. So yeah, just some of the details if you want to move to the next slide. So yeah, one of the things obviously here is moving to AZ API is kind of a breaking change behind the scenes, but we want to make it seamless for customers. So in 99% of cases, which is a kind of a guess, but we think looking at what we've got that in most cases it's going to be completely seamless for module consumers, because we'll be able to use a moved block behind the scene, and that'll migrate the state over to AZ API, and it won't have any impact on users. There are going to be some edge cases. We don't know what they are yet. They're most likely going to be in pattern modules where we might need to restructure something. That's where we might have to provide some guidance in the release notes to say, you need to create these move blocks and we'll help you script them out. And just for this one edge case. So a heads up that might happen, and we'll avoid it as much as possible, but there's a chance that some modules will need a little bit of extra to get them migrated across. So next slide. Yes, so some of the things, this is more for module developers, but we just wanted to share. We want to move from, well, it impacts users as well, actually, sorry. But we might have to update the interface for our modules in some cases. So most of the time now, we have to supply a resource group name. We're going to move to another attribute called parent ID, which is the resource ID of the resource group instead. And this is so that we don't have to use data sources and things like that to look up the resource name. AZ API needs that subscription ID. So we are going to move to that for all modules. So this will be an update to all modules that are resource modules, basically. Using the data source causes problems behind the scenes, so that's why we don't want to use that data source. Next slide. So Matt is working on a new utility module. He's actually working on a couple of utility modules, which will basically do the work of helping us migrate the modules to fully AZ API. So things like diagnostic settings, private endpoints, resource locks, whatever else we've got in the interfaces will be migrated to AZ API, and we're going to abstract that away into this utility module, which will do almost everything that's needed. And that just means that for module developers, it'll be pretty straightforward to move across. So next slide. Yeah, and this is one that's for kind of module developers to make it a nicer experience for customers. So response export values is the outputs from an AZ API resource. We're going to mandate that is not an empty list by default. The module developers have to be specific there. So if you don't do that, you get quite a noisy plan. Even though nothing's changing, you'll see like it's going to update all these things and it looks like lots of stuff's changing, but nothing's actually changing because it's just outputs of the module. So we're going to mandate that the module developers only export what needs to be exported for outputs of that module. We're also going to do replace triggers. So this is where something like a resource group name or location, right? You can't update a resource group name or location. That has to result in a destroy and create plan. But there's other things in different resources that also do that, which can't be automatically detected. So a module developer will update that to make sure that the plan is correct for those things, and it will indicate that if it needs to destroy something, it needs to destroy something. And we touched on this earlier, but we're going to use retry instead of time sleep across the board, right? We're going to use that functionality to make sure it's a nice experience and it doesn't fail randomly because it's timed out or something like that. Yep. So next slide. Oh yeah, and that was everything about moving to AZ API. This is just an extra thing that I wanted to add in. We've recently added the ability to run Terraform tests as part of our CI/CD pipelines. So we had this in behind the scenes before, but it wasn't actually part of the GitHub action. So we've added this in as part of updating one of our ALZ modules. And this now supports unit and integration testing. So we've got two different runs that happen. The unit testing doesn't need any credentials for Azure. The integration tests do need credentials for Azure. So they run as separate parts of the continuous integration pipeline. And yeah, check out the subvending module. We've just migrated it across to AVM, and that has got these unit and integration tests in it. That was everything from me. I'll have a look at the chat and see if there's any questions.
Awesome. Then, yeah, let me take me over. So thank you very much. Yeah, let's have a quick look, a very brief look on some bicep updates where we stand since the last community call. First things first, with what I will kick off the child module. So it's not a new topic. We just want to essentially give a brief sneak peek of what we are doing there and what has happened since. First things first, we published quite a few child modules. So as you can see here on the screen, it's about 45 of them, selected as per what the community essentially requested. So we originally started, I think, with the subnet module, and then we went over to those issues and published all the remaining modules to effectively prove the processes, to maybe sort out some issues in the process that we've identified, work, as you can see here on the left side, on some of the documentation. So we have a spec, that's one thing, sure. But more interestingly, we have the child module publishing guidelines, essentially. When it comes to child module publishing, it's relatively straightforward in the sense of that from the module perspective, you really only need 2 additional files. One of this is the version.json file. Makes sense, the child module would be published on its own. And then a changelog.md file, something we introduced also a while back to essentially track the changes for each of those versions, right? So that somebody knows, there's a breaking change, maybe what do I need to do? And then the module itself is per se ready. The bigger problem is the process, and that's something I'm going to touch on here on this slide. So ever since the POC on the far left side, we know, and this is true for all the AVM modules, that for the first version of a module to be published, it needs to be onboarded to the registry. Specifically, it's called a MAR file where we need to onboard it to, and this is unfortunately a manual process, which is why it is unfortunately required that for new child modules as well, if they are needed and supposed to be published themselves, that those are requested. We can do this in bulk, right? We can have, let's say, 10 modules, for example, be prepared, but we need to know this essentially before a module with this version.json and changelog.md file are merged. The process itself, it works. You can see it on the bottom left. For example, with the subnet module, we have 2 versions there. We have some tests implemented since that makes, for example, sure that if you change something in child module, that the version of JSON needs to be updated, but also that the version of JSON and the changelog of the parent needs to be updated because, right, in the bicep case, there are the changes of the child are always also changes in the parent. We created this issue that I mentioned before where you can request a number of child modules if they want to have them published. They don't necessarily need to be already implemented, but obviously if they're not implemented yet, it will take a moment longer to actually get them there. Then throughout the pilot, we essentially worked on this continuously, and in this flood symbol scenario on the right side, ideally we would naturally publish all the child modules that are available there today. Due to the issues that I mentioned before with the manual steps that we are still working through, we can do this, but we are still working on making the situation at least a bit better, for example, by automatically validating if a module was already onboarded to the MAR file or not. So that we don't end up in a scenario where a module is merged, is in theory published, but doesn't actually show up for users, because that's effectively the effect that this has. Good. Then I'm gonna hand over to Erica for the Manage HSM audit.
Hey everyone. Jack just provided a spoiler about this functionality beforehand. We're happy to announce that for AVM Bicep, we integrated the Manage HSM customer managed key encryption to pretty much all the modules that are currently supporting this functionality. This was done and integrated on 16 resource modules today. And for each of those, we also provide a usage example, which is tailored on the usage of the resource, specific resource with managed HSM encryption. This usage example you will find both as usual in the test folder end-to-end and in the README file. That means that you will have a copy-paste ready snippet to test for this functionality. Currently, the continuous validation is skipped, and the reason for this is that we wanted to limit cost for our contributors. So, of course, before publishing the functionality, we validated it internally, but we are just keeping it from continuous validation. And we mentioned the same also as usual in the README file. Another thing that we added is publishing a table in the AVM website. This is a table listing all the consistent features and extension resources that we implement in our resource modules. This is, for example, private endpoint, managed identity, or specifically CMK. We, along with all these, we added a new column for specifically mentioning if the module supports CMK with managed HSM. Now, it's not taken that if a resource supports CMK, it also supports CMK with managed HSM. We have a few examples, and for instance, the Azure Container Registry itself currently supports CMK through Key Vault, but not with managed HSM. So if you will find this difference in the table, doesn't mean that we are missing the implementation necessarily, but that the resource itself doesn't support it. Now, for the next slide, we are drilling down into the implementation. But before going there, I want to read the message that I have seen in the chat. When you are consuming a module, it doesn't matter how the internals are made. It means you can focus on just the module inputs. And that's exactly what we had in mind when developing this feature. So we put some effort in keeping the current CMK shared interface as is, so untouched. We are still having an input for an object customer managed key that optionally includes some properties like the key vault resource ID, the key name, the key version, if supported the auto rotation enabled, and the user assigned identity resource ID. The key vault resource ID is the pivotal input in this case. Through that, this can contain resource type of, specific key vault or the managed HSM. Based on that, the logic is just transparent to the user from the input. All the complexity is done within the module, and the complexity is basically to understand which type the resource, the key vault resource ID is, and based on that, encrypt with the right resource provider. So either the key vault or the managed HSM as an encryption outcome. We also had in mind the least privilege, so we validated that the deployment identity does not require any airbag or local airbag in this case at managed HSM parent resource, but only on the key level, so only on the specific child resource that is used to actually encrypt the resource. That is it. I mean, the main point is that we avoided breaking changes for users. So, we are happy to share that for the moment, all the modules that were supporting managed HSM are published with that functionality. That's all I had. I believe I will hand over to Jack now.
All right. So thanks for those of you who stuck with us, but this is an important one. So anybody using Bicep will know that we have a long-running issue about a 4 meg limit Bicep template. So like when you get an ARM template that is bigger than 4 megabytes, it won't deploy, it will fail. It's a known issue. It's been there since sort of day one of ARM. However, from persistent asking about this problem, and customers keep raising this, from conversations with the product team at Ignite, they have confirmed that they are actually going to take another look at this and look at solving this within the next couple of sort of semesters. So sort of some point in 2026, they actually want to resolve this so that you can deploy templates of bigger sizes than 4 megabytes. So what I will say is stay tuned to the Bicep community calls, because they'll talk about it more on there. We're involved in helping to review and influence specifications and designs that we're working with the engineering teams on this. But from initial discussions, it doesn't look to change the deployment mechanism or anything like that. It will just be behind the scenes that if the template's bigger than 4 meg, it will be handled in a different way and therefore avoid this limit. So amazing news for us in AVM Bicep, because we get this quite a lot with some of our larger pattern modules, and right now there is no option but split them up. But this will hopefully mean that you can just have one template, and we can carry on building bigger and bigger pattern modules for you. So amazing news. You can see the issue down there in the chat if you want to add support and add weight to that, but know that this is now being looked at. So amazing news. And with that, I think that's us towards the end, right? We're just at the Q&A. So I mean, we don't really have time for Q&A from the community. There's been lots of questions in the chat, which has been great, and hopefully we've answered most of those. We did have some from GitHub though, right, Charlie, that you've put here. So
the second one has
hopefully
been
we've
answered
answered
through the presentation, but yeah.
Hopefully we've answered the second one now from Vijay Manda about RM versus AZ API, and Jared covered that. The other one around that was raised by David Pazdera, who I actually spoke to at Agnite, was on the new migration agent, right, which I also covered in Scott's when I was talking about V1, and this was mentioned in Scott's keynote. So it does absolutely use the existing ALZ accelerator and therefore the AVM modules beneath that. So yeah, amazing work by all the team to get us there. So another use case for AVM. But yeah, with that, I'll hand back to you, Charlie, to wrap us up.
Yeah, thank you so much for everybody listening and sticking with us, because we massively ran over. One promise: we'll do better next time. We'll either schedule a bit more time with you all, if we think we have more content, or we will just schedule a community call a bit before. But thank you to all the speakers, amazing content, and thank you for supporting this AVM project in the community, inside Microsoft, outside Microsoft. The adoption is great, so thank you to the entire community. With that, I wish you a great rest of the day and the week. Thank you so much.
Thank you.